Thank you. And now I'm very pleased to introduce Sean Faulkner, who is joining us in the studio. Good morning, Sean.
Hiya.
Hi.
I'm Sean from Kersten. I've got a few hats on these days, so as well as working for Kersten, who provide equipment for managing weeds, we do mechanical weed management as well as hot water, hot air, electricity. I also am a trustee now for Parks for London, who produced the integrated weed management guidance, and I do a bit of auditing of councils' integrated weed management and help them write plans. So if any of you guys need help with that, I'd be happy to oblige. Today, I wanted to talk mostly we've been running with Control and Bracknell Town Council. So these are some real-world trials to try and measure exactly how the... Apparently my mic isn't working very well. Hopefully you can hear me. So the trial is to measure exactly how pavement ecology reacts to different interventions across different baseline levels. So we have set up a variety of sites. There's 6 sites across 4 different locations in Bracknell, mostly at different parks. And on each site, we've got a series of plots in 10-metre linear lines, or 25-metre linear stretches, or 10 by 10 boxes. So it's replicating real-world situations, verges, path edges, open spaces that you might be treating with pesticides. So each site then is split up into 4 different plots. So we have a control plot, which we're just letting whatever grows grow. And then we have a spray-only plot, so that's kind of a non-integrated approach, just killing off what is there. And then we have a brush-only plot, which again is non-integrated, but it's removing all the soil and detritus that's on the side as well as the weeds. And then we have a combined integrated brush and spray plot, so that we can see the difference between doing the different processes. And we're measuring quite a lot of different things at these plots. So we've got 5 distinct markers at each plot that we're taking images of and tracking different data. So we're seeing exactly what weed species are present there. We're measuring the soil depth precisely in millimetres with a vernier gauge. We're measuring the weediness scale, which is based on the scale from the Thanet project, and the detritus scale, which is in the Code of Practice on litter and refuse. And then we're measuring, for example, when we're brushing, the amount of detritus that's removed in kilograms, the time it took, and the resulting surface that's revealed underneath. We're seeing what level of damage there is. So this has given us a couple of hundred independent, statistically viable data points to track over a period of time, which gives us a good bunch of data. So here's an example of what we've done so far is the brushing. So while we were brushing 2 of the plots, we did that as a pre-season application. So in February, we went and did this at all the sites so that we're getting back to a clean pavement and we can see exactly what we're doing. So we were using that 2-wheel tractor there with a weed brush to do the job. And the data we have already has presented some really interesting information that we can look at. So one of the biggest things to come out of it was what I've called pavement ecological succession. So we're used to ecological succession in horticulture. In different depths of soil, you get different types of weeds. And there's been various studies that account for that, but not on pavements. So this applies that to what we found in Bracknell on these different pavements or hard surfaces. And we found that it splits up into 4 different stages, basically. So at up to 10 millimetres, you've got a pioneer window where it's just pioneer types of species of weed like moss, evening primrose. And then as you get beyond 10 millimeters, you start getting deeper rooted perennial type plants, things like dandelion, cranesbill, thistle, which will start to enter the pavement, and at the same depth you can get things that can start to cause a bit of damage. And then stage 4, you start getting woodier species, so that happens beyond 25 millimeters. So stage 1, as I've designated it, is where the roots are completely floating, and there's very little risk of getting something entering the tarmac or the hard surface that's underneath. So these are the pioneer species. When we get to stage 2, you have species with the potential to enter the surface and cause damage, but they're still at a floating stage, so a sweep will still remove the whole plant. So the difference between stage 2 and then stage 3 is not the depth, but it's how advanced that plant is in its growth. So by stage 3, you've missed that window where it's no longer causing damage and it's starting to anchor into the surface. And then stage 4 is where you start getting proper structural damage, and those woodier plants have the strength to force open the pavement a lot more, and you get much worse problems. So keeping it away from that 25 millimeter stage is critical. So do specific species require specific soil depths? And we've established through that chart that yes, they do, but we ran some statistical tests to make sure that that wasn't just chance. And when you run a chi-squared test, the likelihood of these plants organizing themselves into those specific depth brackets purely by chance is less than 0.00001%. So this would be the same as flipping a coin 25 times and getting heads 25 times in a row. So in scientific terms, it's as robust as the correlation between a person's height and their shoe size. We also did a Kruskal-Wallis test. So this was more defining where the boundaries were between the stages and making sure that was accurate. And it again showed that fundamentally there's a mathematical difference in the requirements that different species have in the soil depth. So this data shows a clear, undeniable progression, and statistically it's the same as predicting that children in year 6 will on average be taller and heavier than children in reception. So the main point of this is that weeds are no longer just a cosmetic problem. We can't consider them as such. We have to consider them as a civil engineering problem that can cause damage to the surface in combination with the soil itself, and therefore treated appropriately. And applying a preventative sweep and other preventative maintenance in total across a year might typically cost less than £10 per metre squared. A sweep is significantly less than that, but if you start treating the crack up the edge of the curb, for instance, sealing that kind of maintenance is in the preventative side. And then as you get into the more structural damage, that can cost upwards of £100 per metre squared as you start treating potholes and filling big areas you have to resurface. So the difference between removing the soil and not removing the soil is costing councils a fortune over time. Since starting the trial, I've been doing a few audits for councils, and one up in Scotland in particular was very interesting. That's what this is based off. So we analysed basically their complaints data over 24 months, looking at weed complaints and gully emptying complaints and pothole complaints. And we found that when we overlaid them, there was a significant correlation between the three of them. We also looked at some on-site information. So we went to those streets and we measured the soil depth at those hotspot streets that were causing the worst problems. And we discovered that 64% on average, if we extrapolate that, of the network is at stage 3 or 4. So it's already past the window, and that might be common across a fair few councils. So the sooner we can intervene in that window, the more damage we can prevent. We looked at financial modelling, so we looked at how much that soil was going to cost to remove and what the payback period for doing it would be against the extra damage it was costing the council, and also looked at how they were doing against various legislation and guidance. So this is the hotspot overlay, and we overlaid 1,654 complaints on weed control and 8,000 complaints on gullies and thousands and thousands of potholes. And it was really interesting. There was some clear hotspots, and when we went to measure against those, it turned out that there was a perfect line between the soil depth and the amount of complaints. So the deeper the soil, the more complaints there were. So we also then ran some statistical analysis and showed that the soil is basically causing the 3 different problems. So it's causing or a proportion of the problems. It's not 100% responsible for the problems, obviously. But the soil was causing a proportion of the weed problem. It was causing a problem with gullies, and it's also causing a problem with potholes. And areas that had high levels of gully and weed complaints were likely to have 2.5 times the amount of potholes. So how does soil contribute to edge failure and pothole formation? Well, there's an engineer over in the States who's credited for a lot of work on this, called Tracy. And Tracy's law dictates that if you lose the edge, you lose the road. And what tends to happen is that the freeze-thaw cycle, because soil is holding water against the surface and it's trapped there, when it freezes, it expands in little pockets and forces them open. And as that happens, roots can then penetrate that and exploit those issues to cause further damage. And when you lose that support at the edge, you've lost the support for the middle of the road, and the middle starts falling away, and you get these hairline fractures up the middle of the road. Water gets into those, expands, and forces them out into potholes. So if you maintain the edge, you stand a lot less chance of having problems in the road. In the UK, there's a statutory duty to keep highways clear of litter and refuse, and this includes detritus. So in the Code of Practice on Litter and Refuse, it explicitly states that detritus is one of the things that you have to keep the road clear of. And there's a grading scale for this detritus. So if you find it interesting, you should refer to that Code of Practice, and you can see this grading system. Grade A is where it's supposed to be, so that you can see all the lines and the curb edge is clear. And then any grade past that has to be rectified within a certain amount of time back to grade A. So the point really is that at the moment in a lot of councils, weed budgets are often very separate to road maintenance budgets. And actually, it's worth reconsidering that and thinking about where some of our preventative maintenance is affecting the pothole budget. Some councils are approving millions at the moment per year in emergency pothole filling budgets, and some of that could be put towards preventative weed management, rather than relying just on the traditional pesticide budgets, which are sometimes more concerned with aesthetics. So how can we tell when a road is in stage 1 or stage 2, stage 3 or stage 4? Well, As well as just looking at the plant types, we can also measure the depth of the soil, which gives us a good indicator. And then when it's in stage 2 or 3, we can tell by doing what I term a kick test. So it just takes a second to do. You just literally kick the soil and the weeds that are in there. If the weed moves with the soil, with your foot, then it's in stage 2. If the weed stays anchored, then it's in stage 3 and it's entered the surface. So what we're getting out of this is to prioritize both stage 2 so that you can prevent streets going into the further damage and paying a load more money for rectifying that, and also attacking some of those stage 3 and stage 4 to stop that getting any worse. Another thing we got out was we measured the amount of soil we were taking off, and I think some of that's quite staggering, really. These weren't sites that looked overly messy to begin with, but on one of them, a single 10-metre plot, we removed 280 kilos of soil. So in 280 kilos, you can grow a massive amount of weeds. If you don't have that, the reaccumulation rate in a plot like that, we're going to measure over the trial period, so we'll be able to give you some more accurate intervention times, but it's generally going to be an awful lot less than 280 kilos a year in 10 metres. That's probably been left quite a number of years. And the average detritus removed on all the plots, so some of them were 25 metres, some of them were 10 by 10, was 142 kilos. So this means that we can no longer wait for weeds and then react to them. We can start acting preventatively, and we're preventing more than just weeds, we're also preventing damage to the surface. So we go from a reactive wait and see type approach to a very predictable preventative approach, which gives you much more peace of mind that you're stopping the clock on the damage and preventing millions being spent on potholes. Weed control is no longer just about a cosmetic horticulture exercise to appease residents. It's a fundamental data-driven preventative maintenance strategy for your paved infrastructure. Beyond introducing more sweeping and mechanical weed control into your integrated weed management approach, there's a lot else you can do to reduce the amount of detritus that's entering the system. Some of it will be in the way of barriers so that you can prevent it migrating onto the hard surface. And you can also look at planting regimes. I know there's a lot of programs for replanting areas with wildflowers, for example, but it might be worth considering that the types of plants you are going for could be lower litter plants and lower growing plants that require less maintenance, that can still add the same kinds of benefits for biodiversity while also reducing the amount of work you have to do for maintaining the road. Another thing we found so far in the trial is that residents were very happy to see mechanical approaches, because the immediate nature of seeing a clean surface, they can see something's being done, and they were saying things like, it's great to see a new initiative, I hope it happens across the whole town, that's really good. It's a great brush, great job, I hope it's successful. And we had, so far, just having been on site, doing the actual work a couple of times and measuring results, we've collected 15 or so different impressions from people, and they've all been overwhelmingly positive. Thank you very much for listening.